All right, so we are starting with Chapter 1, Transformations. And we're just going to start by taking a look at these two equations. How are they similar? How are they different? Okay, now let's take a look and go through some of our notes. So a transformation of a function alters the equation and any combination of the locations, shape, and/or orientation of the graph. Mapping relates the points on the original graph to the points on the transformation, and mapping notation is alternative to function notation. This is an example here of mapping notation where the x has moved 3 units and the y hasn't changed. In this mapping, we are showing that now the y values have all been moved down 2. So again, you start with an original point, the x's haven't changed, and then the y's move down 2. A translation is a type of transformation that moves the location up, down, left, or right. A translation does not change the shape or orientation of the graph. So a translation means move. All you're doing is moving a graph to a new location. We have 2 types of translations. We have horizontal and we have vertical. Horizontal translations affect the value of x, and you guys, that should make sense because x runs horizontally, so horizontal translation moves it left or right. A vertical translation affects the y values, and again, that should make sense because the y axis runs up and down, so a vertical translation affects the y values. So what we call this h and k. So a horizontal translation is h, a vertical translation is k, and in function notation, that looks like this. All right, so for our first example, we're going to graph the functions x squared plus 2, and x minus 5 squared, all on the same grid, and describe the translations. So remember that you can sketch anything using a table of values, and we're going to start with the original function, y equals x squared. From Pre-Calc 20, you should probably remember what this original parabola looks like. Well, let's go through our table of values just to make sure. So when you make a table of values, you plug in some x's. We'll plug in 2, 1, 0, -1, and -2. And then the matching y values are the squared of the original x's because it's x squared. So 2 squared is 4, 1 squared is 1, 0 squared is 0, -1 squared is +1, and -2 squared is +4. So if I go to plot these original points from the parabola, they're at 0, 0, 1 and 1, 2 and 4, 2 and 4, 1 and 1. So original parabola would look something like that. All right, so now we're going to look at what happens if it's x squared plus 2. So if I would just add on to my table here and say x squared plus 2 is my new y value, that means the 4, when we go x squared plus 2, is going to be 4 plus 2, so 6. If I go 1 plus 2, we get 3, 0 plus 2 is 2, again, 1 plus 2 is 3, and 6. So my new coordinate would have an x value of 2, but a y value of 6. So 2 would actually be at 6. 1 is at 3. Oops, 3 right there. 0 is at 2. -1 is at 3, and -2 is at 6. All right, so let's graph this last one then. We're moving at 5 units in the positive x direction. And again, that's from my original parabola. So my vertex is now going to be moved over 5 units. And each point will also be moved over 5 units. But the shape itself has not changed. All right, so let's try another example. This one, we are sketching the graph of absolute value, x minus 4 plus 3, and we're going to try this one by mapping. Now, before we can do mapping, we have to always know what the original function looks like. So without the 4 and without the 3, we just have the function absolute value of x. Now remember with absolute value functions, what an absolute value function is the distance away from 0. So when a number is absolute value, that means it's always positive. Because even if you have a number like -3, -3 is still only 3 units away from 0. +3, it's only 3 units away. So when we make a table of values, again, I'm going to plug in my x's to, not 2, 0, 2, 1, negative 1 and negative 2. And then when I take my y values to be the absolute value of x, 2, 1, 0, but then positive 1 and positive 2. Because again, negative 1 is just 1 unit away from 0 when you absolute value it. So when we plot these, the first point was 2 and 2, 1 and 1, 0, 0, negative 1 and 1, negative 2 and 2. So you get this kind of V-shape graph. So now what we're going to do is now we're going to include the minus 4 and the plus 3. So when you think of our function notation, the minus 4 is in the h spot. So that means that our h value is actually a positive 4. So this whole graph is going to move 4 units in the positive x direction. The k value is the positive 3. So this whole graph is also going to move 3 units up. So again, if h is positive 4, that's 4 units right. And k is positive 3, so that's 3 units up. So I could take this V-shaped absolute value graph and move it all 4 units over and 3 units up. So my vertex is now going to be up here. And then again, that V-shaped graph would be from that point. Okay, so this same question could be done with mapping. And our mapping equation is that x and y changes to x plus h and y plus k. So basically what we're doing if you're mapping this is you take any point, and I would take the vertex because that's kind of the key point on this graph. So I take the vertex and it's at 0, 0. So my x is 0, and then my h value is 4. So the point 0 has been moved 4 units to the right. And then the 4. And then the y value is 0 as well, and that moved plus 3 units up. So my point on 0, 0 is actually 0 plus 4, so 4, and 0 plus 3, so 3. So the point 0, 0 has now moved to the point 4 and 3. Okay, here what we've got is our original function is the blue graph of f of x, is x squared. And the new graph is the g of x, the red graph. So I want to know, how did I move from the blue graph to the red graph? Let's just say this in words. How did we move over? How did we move up or down? So looking here, from vertex to vertex, our graph has moved over 1, 2, 3, 4, 5. So left 5 and down 2. Now we're going to put it into our equation. So in the h spot, I'm going to put a negative 5.
Should it be a positive 5?
Yeah. And it's going to look positive because when I plug a negative into here, the double negative is going to change to a positive. And then my k value is negative 2. So this would be, in function notation, the transformation from the blue graph to the red graph. Now I want to show you one other way you could write this, because you know that this graph is the graph of x squared. F means any function. F just is showing you how the transformations went. But what we could say is that this is actually the graph of x plus 5 squared minus 2. So how these two are different is, again, this one actually shows you that you had a squared function that's moving 5 left and down 2. Whereas this other one is just showing you that it's any function, but that function was moved left 5 and down 2. So these are two different notations. Again, what they're called, the top one here is called transformation notation. And then this one would be called function notation, because it actually shows you what the function is. So those are the two types of notation, the transformation notation, where it's only worried about the transformations, and the function notation, where it actually tells you what the function is as well. So please pause the video here and try the transformations on your own. And then just check your answers with the ones on the board. Example 4, I'm going to try the first one with you, and then I'll give you a chance to try the other 3 on your own. For each of the following translated functions, determine the value of h and k and describe the effect they will have on the function. So you guys have to be careful here. See how the k is over on the side with the y? So what I would start by doing is moving it, by adding it to the other side. So this function is actually y equals f of x plus 5. Now that 5 is your k value. So k equals 5. And if k is positive 5, what in words is happening to your graph? Up, right? So this really means that it's going up 5. So for this question, I want you to state the h or the k, and also in words, tell me how that's moving, up, down, left, or right. And you can check your answers with those on the board. Now we're going to go to example 5, last example for today. What vertical translation is applied to x squared if it passes through the point 4 and 21? Now this is tricky, okay? We're applying a vertical translation, which means we're applying a k value. So, think about this. We have the point 4 and 21, and that point has been vertically changed, okay? Which means the y value has been changed. What would my original point have been? If I had 4 for the x, 16. 16 because the original function was x squared. So if I started with an x value of 4, the y value would have been 16. So what did my y value change by to get to 21? 5. Up or down? Oh, it moved up 5. So that means, if you think about this in mapping notation, the x value stayed the same, but the y value moved up 5. So the vertical translation was that the y moved up 5. So now we're saying we have a horizontal translation, which again means the x is going to be translated and not the y. And the point is 5 and 16. So my new point is 5 and 16. So let's think about what should my original point be. Again, 16, the y value did not change. So what should the x be that was matching with the 16? 4, right. So if I was at 4 and 16 and now I'm at 5 and 16, what happened to my x value?
-1.
Plus 1. Because we would have added 1 to go from the 4 to the 5, and the y value didn't change.
Yeah.